Internal Routing Protocols Part 4, OSPF Configuration Fundamentals. In the previous nugget, we focused on all the concepts of OSPF. Well, maybe not all of them, but most of them, all the major concepts of OSPF. So I plan in this nugget to spend all of our time focusing on the configuration of OSPF. As a matter of fact, as we go through, we're going to build out an OSPF network piece by piece, starting off by deploying the backbone on Area 0. And we're going to deploy that on an Ethernet-based network, because I want to talk with you a little bit about setting up the DR, setting up the BDR, some of the neighbor relationships that are going to form, and most importantly, in my opinion, some of the neighbor relationships that will not form on that Ethernet segment. We're then going to add additional area support one by one. We're going to start off by deploying an additional normal area, just a standard OSPF area. We'll get into some of the stub areas, and then we'll get into a totally stubby area and add external routes coming in from a RIP network. It'll be great. From there, we'll get into inner area summarization. These will probably start splicing themselves into the middle of the configuration. As we start deploying the areas, we'll say, you know what, here's a good summary point, here's a good summary point. We kind of block them off. And then finally, we'll do connecting and redistributing to external domains. And again, splicing it into the different area supports like a stub and totally stubby area and what routes they can receive from external domains. We'll also talk about sending OSPF routes out into other domains as well. So let's begin with the core of our network, deploying the backbone of OSPF. It doesn't look like much now, but it'll grow. This is the beginning of our OSPF network. And as of right now, I have 3 routers that are connected to the backbone, or OSPF Area 0. We're going to walk through the configuration of OSPF on router 1 and router 2. I've already set up router 3 for it, and I've also deployed all the IP addresses to save us some time. Once we deploy this backbone, we'll start creating other areas, all the different area types that I just mentioned for all of these other routers, and start throwing in external systems and so on. But let's begin right here. I'm going to start on router 1 and get my prompt up here. And I'm just going to do a show IP protocols just to show there are no routing protocols running right now. And I'll get into global config mode and type in router OSPF1. Now, hang on. Let me get back there. Router OSPF, and the number is a process ID. And don't forget, this is not an autonomous system. It can be any number that you want to uniquely identify the OSPF process. You can run a different number on all the routers. You can run the same number on all the routers. I usually use 1. That's just an easy one for me to remember, and that's the one I'll use on all the routers here. Now, the first thing I do on all the routers is I type in the router ID command. The router ID is the identification of this OSPF router in the entire domain. Each router will have its own unique router ID, and when you're doing the CCIE lab, it'll be something like this, where you'll have routers named router 1, router 2, and router 3. It's usually a best practice to set the router ID after the router's name. For example, router 1 will be 1.1.1.1. So that way, when we are doing show commands and looking at the neighbors, or doing a show OSPF database command and looking at the topology table, it's really easy to identify where the routes are coming from. So that's usually what you'll do in the lab. Now let's talk real world. In the real world, you'll typically set the router ID to some number, like what I've seen a lot is people will use router ID 250 dot something. Because 250 isn't a real IP address. It's one of the Class E's experimental use that they embed in mice and who knows what else. You're never going to see that IP address. 1.1.1.1 is a real IP address that potentially you could see somewhere, as well as 2.2.2.2 and so on. So it's good to hard code the router ID. The router ID can also be set using a loopback interface or just the highest IP address on a physical interface, but those could change. If you hard code it with the router ID command, it will never change. Voila, we've done that. Now we can set the network statement. I'm going to jump on router 1 and I'm going to turn it on for the network 172.16.2. Now you can see it's a Class C network, and I'm going to use the full wildcard mask this time, and I'll show you the shortcut when we get to router 2. I'll type in network 172.16.2.2.0 with a wildcard mask of 0.0.0.255. What that says is any interface that starts with 172.16.2 will run OSPF. The 255 says, I don't care what that last digit is. It can be whatever you want it to be, and I'll run OSPF there. From there, I'm going to type in area followed by 0, the area ID. Now I have OSPF running on this router, and it should begin to form a neighbor relationship with router 3 up here. Router 3, I've already set its router ID at 3.3.3. Oh, there it is. We see the status message come across. Neighbor 3.3.3 has gone from loading to full. Now in the previous nugget where we talked about the OSPF concepts, we talked about all these neighbor states, and that is key. It is very key to know what the different neighbors are going to be. So I'll type in show IP OSPF neighbor, and I see that 3.3.3.3 state is full. It is the DR, which probably means we are the BDR, the backup designated router, and we're good to go. So at that point, we should be ready to jump onto router 2 and to configure OSPF on router 2. And I'd like to show you a few shortcuts here. First, let me do a show IP interface brief so I can see the IP address. It's been assigned to the Ethernet interface. We're up. We're good to go. The first thing I want to show you is how important it is to set the router ID as the first thing that you do. Watch this. I'm going to get into global configuration mode and type in router OSPF 1. Go into that process. Instead of setting the router ID to 2.2.2.2, which is typically the first thing I would do, I'm going to turn on OSPF for the network. I'll type in network 172.16.2.2. I'll show you the shortcut here. I'm going to use a wildcard mask of 0.0.0.0. By doing that, I kind of look at it like laser surgery. Before, we used a wildcard mask of 0.0.0.255, which said for any interface that starts with 172.16.2, enable OSPF, and I don't care what that last digit is. This one is like laser surgery. We're focusing in on exactly the interface that we want. I want OSPF turned on exactly 172.16.2.2. That way, if later on down the road I turn on another interface that starts with 172.16.2, I don't suddenly have OSPF running on it and I wonder why. This way, I focus and run it on exactly the interfaces that I want to. So I'll type in area 0 to complete the command. Now it's going to start running OSPF on that interface and start forming the neighbor relationships. Let me hit Control Z and do a show IP OSPF neighbor to see if it's formed some yet. Good, good. We have formed neighbor relationships with both router 1 and router 3, and I also see that they are the DR and the BDR. Now let me go in and set my router ID. Router ID, and by the way, you can't abbreviate that command by typing in router or else it'll think you're doing some kind of router command from global config mode. You have to type the full thing. Router ID 2.2.2.2, and watch this message. Reload or use the clear IP OSPF process command for this to take effect. Why? Well, the reason why is because 1.1.1.1, or router 1, and router 3 have already formed a neighbor relationship with router 2, and they know it as 172.16.2.2. Let me jump over there, do a show IP OSPF neighbor command, and there it is. That's what they know router 2 by. For the router ID to change would require that I go to router 2 and reset the whole router process. It's not a big deal, especially in the lab environment. In the real world, it may cause some downtime. But in the lab environment, you just have to type in clear IP OSPF process. It's just kind of a hassle. So it's usually best to set your router ID before you do anything else. Now, the other thing that I want to show you is, let me do a show IP OSPF neighbor on here. And okay, to reform those neighbor relationships, I want you to see that on this Ethernet segment, we have 3 routers right now. We have router 1, 2, and 3, but what if we added another router? And let's say we added router 10 over here. Now, router 1 is the DR. Router 2, or router 3 is the BDR. Oh, I did that backwards. Router 1 is the BDR. Router 3 is the DR. Router 2 is considered a DR other, right? Because it's neither. It has formed, let's look at it, it has formed a full relationship with router 3 and router 1. What kind of relationship would it form with router 10 over here? Forgive my penmanship. What kind of relationship would it form with that router over there? It would end up forming a two-way relationship. If I added another router there, I would see in this list, it would say 10.10.10.10 if that's what I said its router ID to be, and the state would be two-way/dr other. When I first saw that, I got freaked out. I looked at it, I was like, oh my gosh, two-way, it hasn't completely formed a neighbor relationship, because if you saw the previous nugget, you saw that two-way was just kind of a halfway formed neighbor relationship. On an Ethernet segment, and also when we get into frame relay in the following nugget, when we get into the advanced OSPF configuration, you will see two-way relationship. That's how it's meant to be. Router 2 doesn't send its routes to router 10. Instead, it sends them to the DR and the BDR. They figure out what that means, and they will handle sending it to router 10. So don't worry if you start seeing two-way relationships in that list. That's how they're supposed to be, at least on a Ethernet segment where we have more than 3 or 4 neighbors, and on a frame relay segment where we start having specific routers set as the designated router and backup designated router. Okay, so we've added the backbone area. We've now got that set up and configured. Let's go ahead and start expanding this topology. I'm going to change this over, and you'll see it build out as we go. I'm now going to add router 4. And router 4 is going to be connected via a wide area network link, and for now this will just be a normal area. We have the IP addressing already configured, 10.1.24, and you'll see the scheme as I go throughout the rest. That would be router 2 to router 4, and then we'll have 1 and 2, and this is a 30-bit mask, so we're just on the wide area network link. Let's go ahead and set up router 4. Now, I hate to say it, but setting up router 4 is going to be a little anticlimactic, so I'll fly through the configuration. I'll go into router OSPF1. We'll do router ID. Almost forgot it. Router ID 4.4.4.4. Network 10.1.24.2. All right, you ready for the difference? There it is. Compared to the other configurations, we've now put it into a non-backbone area, where I think something... It's not going to be too different, but I think the conceptual difference will really come in on router 2. As we go on router 2, which again is the one connecting area 1 to the backbone, as we go into router 2, let me just do a show IP interface brief, make sure we're there. And we are. Router OSPF1, 10.1.24.1. Now it's the same command, but what has router 2 become? What conceptual router has it become for OSPF? You probably got it. It's an area border router. It's now an ABR. It's connecting area 0 to area 1, and router 4 has its own topology database. It has its own map of area 1. Area 0 is where a nice summarization point can begin. Now, because this was somewhat of a anticlimactic part of it, configuring a normal area, I'd like to add a little spruce to it. I'd like to add a little spice. First off, let's hop on over to router 1, which is at the bottom of our topology, and let's do a show IP route. So we can see the routing table and see, voila, we have learned our first OSPF route, and it is an inter-area route, meaning it has come from a separate area. If we go over to router 4 and do the show IP route, you see that we've learned about 172.16.2.0. Now I promised I'd do a little summarization, so let's do that on router 2. I want to summarize on router 2 that when this area 0, is advertised, it's going to come across with the standard 16-bit mask. I'm going to yank the 24 off, and I'm just going to go back to 172.16. So here's the command to do it. Remember, in OSPF, area border routers are the only routers that can do summarization besides the autonomous system boundary router, anything that connects to the border. So let's do area 0, followed by range, which is going to tell pretty much the summary address that we want to inject. And I'll do 172.16.0.0, followed by the mask that I'd like to apply. And I'm going to change that back to a standard class B address, so router 4 will kind of get a summarized area. And then we'll follow it up by, you could type advertise or just hit enter. You can see advertise or not advertise this range. So we'll hit enter, and at this point, router 2 is now injecting a summary route for area 0 over to router 4. Let's verify. Hop on down there, do a show IP route. And what we see here is that we are now receiving a 16-bit mask. Now, we didn't really accomplish anything by doing that because there was only one 172.16 network in the first place. However, we did get to use the syntax to do an area summary on an area border router. Where I think a little more excitement is going to come in is as we get into the, let's jump into adding a stub area. Here's what we're going to do. We now have not only, oh, let me get my little flashing box out of there. We now have not only the normal area, we've added area 2. It's going to be a stub area. And in order to see the effects of a stub area, I'm going to, at the same time, create an autonomous system boundary router on router 1 and have that route to an external RIP version 2 domain. So yes, we're going to start doing redistribution. We'll have routes coming in from router 9 from the RIP domain 172.30.x.x coming into this network. Now, if we know our area is correct, those routes should end up in the normal area just fine and in the backbone. The stub area will filter them out because the routes do not end up in a stub area. They do not allow external routes. And I think you can already imagine what this one will become. It will go down to the final totally stub area once we get to the bottom. So let's begin. Let's hop on to router 3 and begin configuring area 2 as a stub. So here we are on router 3. I'm going to jump in here, do a show IP interface brief, and show that we do have a connection over to router 5 up here. So let's get into global config mode. And we're going to configure this the same as the area border router we just did a moment ago. Router OSPF 1, there will be one slight change, 35.1. So I'm turning on OSPF for that interface. Now we're going to type in area 2. But we haven't told it that area 2 is a stub yet, so let's do it. It's the most logical command you can have. Area 2 stub. Now, stub is one of the flags that must agree on neighboring routers in order for them to become neighbors. So we need to make sure on router 5 and on router 6 as we configure them in the stub area that we need to type in area 2 stub as well, or else they won't even form a neighbor relationship with router 3. So let's jump over to router 5, global config mode, router OSPF 1. This is the first time we've set up router 5, so we'll give it its router ID and follow it up with the network 10.1.35.2, area 2. This one has two connections, 10.1.56.1, area 2 as well, and then we'll type in area 2. You know what? Let me hit Control Z and do a show IP OSPF neighbor. Okay, they're not even showing up. I wasn't sure if we'd actually see it in there as kind of a half-negotiated session or not. So we'll go back into router OSPF 1 and type in area 2 stub. And at that point, we should start bringing up neighbor relationships with router 3 down here in the blue area. There we go. Router 3 has gone from loading to full. And then finally, router 6, the last piece of the puzzle here. We'll go into router OSPF 1, router ID, all 6s, network 10.1.56.2, area 2, and area 2 stub. So we have now configured a 3-chain router system of stub areas. But you know what? I'm going to let the suspense build. I'm not going to do a show IP route. Because we haven't done any external routes yet. There's our neighbor relationship. We haven't gone over here and started the redistribution process on the autonomous system boundary router, which is router 1 in this case. So if we were to do a show IP route, it'd kind of spoil it because we wouldn't be able to see any of the filtering taking place. So before we do any show commands in that stub area, let's hop on down to, we're going to do router 1 since router 9 is already set up for RIP version 2. Jump on router 1, set it up to redistribute to that external domain. So let's hop over to router 1 here, bring up the terminal, and do a show IP interface brief. That's just like my brainless command. I do that just to get reoriented every router that I'm on. And let's hop on to global config mode and do router RIP. Every time I do that, I just router RIP. I think of the baseball game. Version 2, I'm random, yes. Network 172.30.0.0. So at that point, the bottom router is already set up, router 9, so it's sending RIP version 2 routes. Who knows what's behind it? We'll just say 172.30.x. Router 1, now running version 2, should be receiving them, so we should see RIP routes in its table. Let's exit out and do a show IP route. And sure enough, there they are. We see all of our RIP routes. We see some of the inter-area routes that we're learning from our normal area up here. and the two networks in our stub area are showing up in the router table. So let's begin the redistribution. Now, just so you know, whenever you're doing redistribution, if you are just doing it on a single router, say router 1, and we're sending all the RIP routes into the OSPF network, and vice versa, all the OSPF routes into the RIP network, you don't have to worry about a loop. That's one of the things that I got confused about way back when, is I used to think, oh no, mutual full redistribution on a single router, we're going to have to start filtering to make sure the RIP routes don't end up coming back out of OSPF. Well, if you're only doing it on one router, that router is going to be smart enough, more than smart enough, to say, well, I just sent those routes in, I'm not going to send them back out. Where you'd run into the problem is if you had, say, this router over here was in the OSPF domain and it was connected to router 9, or here's a better one, router 4 has a WAN link to router 9 and you're doing full redistribution there. That's where the loop can end up happening. So I have no fears of coming to router 1, getting into router OSPF mode and typing in redistribute RIP. I'm not going to apply any route map. I'm not going to apply much of anything when we're doing this redistribution, but I will type in the metric, and I will say the default metric for these routes as they come in, I'm going to start them at 1000, and they'll increment from there throughout the domain. The metric type is going to be what sort of route, external route, you'd like to tag this on. With the external route type 1, that means that our metric will increment as it goes throughout the domain. As our routes redistribute into OSPF, as it passes to router 5, as it passes to router 6, it will actually increment the metric so that it can find the best way out of the network. Now, OSPF external 2 routes, the metric will not increment, meaning I've set the metric to be 1000, and it will stay 1000 for those routes, no matter how far it goes throughout the domain. In this case, external type 2 routes are fine. Why? Because there's only one exit point. There's only one way to get there, so it doesn't matter what the metric is. It can stay 1000 or it can increment. There's only one way to get there, so it will always use this direction. So we have the metric type typed in. Subnets, the keyword that only OSPF has that is so easy to forget. If you don't type in subnets, it will only redistribute class full networks. In this case, you see down here I have 172.30.x.x. That's a default class B network. And if I didn't put the subnets, it wouldn't give all the individual subnetworks that I've subnetted out to be. I've said that a lot. And the reason why is I applied a class C subnet mask to all the networks down here. So unless you want to start doing stuff like auto summarization, always include the subnets. Now, when we get into the advanced OSPF nugget in the following nugget of this one, I'll talk about the tag, but I'll introduce it here. OSPF is sweet in the sense that it lets you tag routes. Now, a tag is nothing more than just kind of like a label that you get to put on those routes. It's kind of like if you were going through, let's say you were sitting on an assembly line and you were watching these car parts go by, and it was your job that anytime a strange looking car part was going to come by, to put a little blue sticker on it. So further down the line, they could look at it a little more closely and say, oh, that's a blue sticker part. I want to analyze it a little closer because there may be something wrong with it. Well, think of it in that same sense. We can tag the RIP routes with just a little label. You can pick a number. I'll say 150, so that I can mark them as they flood the rest of the OSPF network. So if I ever get to maybe some router down the line, I'll pick router, well, that's a stub area, so they'll never see them. But we'll say router 4. Maybe I don't want router 4 to see the redistributed routes. Well, here's the beauty. On router, what is that? Router 2, I can say I want to filter all routes that have a tag of 150. So what I'm doing is I'm not doing anything to these routes by putting a tag on them. I'm just putting a blue sticker. So later on down the line, if I ever do want to filter them out, I can match that tag. You're going to see when we get into the advanced OSPF nugget, that is a powerful thing to use for your redistribution. So I think that's it. I'll hit a question mark one more time, and we typed in just about every keyword possible except route map, and that's okay. I'll hit enter, and we're now redistributing RIP into the OSPF network. To do it vice versa, I'll go into router RIP, and I'll do a redistribute OSPF. We'll do process ID 1, and I'll do metric, and I'll set a metric of 10, a pretty high metric for RIP so that these routes won't travel far. And from there, it should be just about it. That's all we really need to do to get those OSPF routes to get into the RIP domain. And at that point, we are mutually redistributing from RIP into the OSPF world. So let's verify it. Router 1's doing the redistribution. Let's hop up to router 3, because it should be the first one to receive them. I'll do a show IP route. And oh, so beautiful. You can see that it's external type 2 routes where the metric doesn't change, and sure enough, you see the metric stayed at 1,000. Even though it crossed some links, it went across the Ethernet link right here to get there, it didn't add the cost of that link. Since it's an external type 2 route, it's going to keep the metric the same. That will never change no matter how far I go in the OSPF autonomous system. If I chose external type 1, it would. So I'm seeing all the 172.130 routes up here. Now let's go ahead and break the suspense on this stub area. I'm going to go to router 5, and if this stub area is set up correctly, these routes should not be there. What should be there instead? A default route. Let's hop up there. Router 5, hold your breath. Show IP route. Oh, I can let it out. OSPF default route. I never put that default route there. That's saying for anything that you don't know about, router 5, anything that you don't know about, send it to your area boundary router, which in this case is router 3. So by creating a stub area, just like we talked about in the concepts nugget, by creating a stub area, it will successfully filter all networks that are outside of the OSPF system. It will never see external routes, although a stub area is not as restrictive as the next area that we are going to configure. Let me go ahead and flash that one at you. This will complete our scenario. We've got the stub up here and the totally stubby that will fill in at the bottom. Remember, the difference being that the stub area filters those external routes, but lets other area routes come in. The totally stubby area, which is a beautiful color, will filter even inter-area routes. So it will not see RIP routes or external routes or routes from other areas. Let's start off on router 7. On router 7, I'm going to jump on and do a show IP interface brief, make sure that my serial interfaces are up and chugging away. It looks like they are. Get into global config, router OSPF1, router ID. Hopefully this is hammering into your brain, seeing these commands again and again. Now I'm going to use a shortcut and put both of those interfaces in at the same time. I'll do network 10.1.0.0. Wildcard mask like that, so I'll just say any interface starting with 10.1 will be in area 3. Alright, so at that point, that's configured. Now, I should mention that a totally stubby area is kind of a Cisco proprietary thing. And I say kind of because, think about it. For a totally stubby area, which one of these routers is going to be doing the filtering of external and inter-area routes into the area? Well, router 1 is, right? Because it's the one sitting on the border. It's the area border router. As it comes in, it's going to say, oh, you're an inter-area route, filter. Oh, you're an external route, filter. So really, the only one doing the true totally stubby function is router 1. So to support that, since totally stubby is quasi-Cisco proprietary, to support that, router 1 needs to be a Cisco router. However, Cisco was brilliant when they developed this because they made it backwards compatible with just the stub area flag. Here's what I mean. I'm going to jump on router 7 and I'm going to configure it as a stub area. Router 8 I've already configured so that it'll save us a little time as a stub area as well. So both of these will have the stub flag. On router 1 I'm going to set it with a totally stubby flag, but that is backwards compatible in the sense that it will communicate with router 7. And since router 1 is doing the filtering, router 7 doesn't know any different. It just knows it's getting less routes than this stub area up here. So let's do that. I'm going to type in on router 7, area 3 stub. I'm not making it totally stubby. I'm going to save that for router 1. So jump up to router 1, do a show IP interface brief so I know where I'm going here. This is the one connected to the totally stubby area. Router OSPF1, network 10.1.17.1. area 3, and the final flag is area 3 stub, and to make it totally stubby, we add the no summary onto there. So that's going to be now a totally stubby area. Control Z, let me do a show IP OSPF neighbor, and we should, give it some time, it'll form a relationship, there we go, with router 7, and notice this, full nothing. Well, remember, this is a point-to-point link between these two routers, so there's not going to be a DR or a BDR, so we won't see them in that case. So there we go. We have a relationship formed with 7. So if I go to router 7, my guess is that, yes, we don't have to guess here. My factual thought is that we will see only the routes in area, within the area, the two connected interface. Notice that we have a summary route for everything else, or a default route for everything else. So it's not learning anything from here, or from the external domain. However, will it still be able to reach them? Well, there's only one true way to find out. Ping 10.1. Let's go all the way up. 56.2. Beautiful. You can tell it took some time because the exclamation points were slower. There's our round trip time. It's able to get there because it's pointing the default route to the backbone and reaching up into this area. So at this point, let me just glance at the screen. Matter of fact, let me pause the recording and make sure that I've got everything here. Okay, I'm back. And there is one more thing that I want to show you. You remember that we did summarization when we were on router 2. We summarized the backbone at the very beginning of this nugget. We summarized the backbone 172.16 into area 1. But it's a totally different command to summarize external routes into the rest of your area. Let me show you. I'm on router 7 right now. Let me jump up to router 3. And I'll do a show IP route. Now you can see we have all these external routes, 172.30.2, 3, 1, 4, 5, and that in this list that are external, and those are just begging to be summarized. So let's jump to the autonomous system boundary router, router 1, and do that summarization. I'm going to get into router OSPF 1. Now you remember, just to review, when we were on router 2, we did the area range command. I said area 0, range 172.16.0.0 with a class B subnet mask, and it summarizes now area 0 into area 1 from router 2. When we're summarizing the external routes, all these 172.30s, instead of typing area range, since the external domain doesn't really have an area, we just type in summary address, followed by the summary address that we'd like, 172.30.0.0 with a class B subnet mask. Yes, it's an easy summarization, but that's what it's there for. So we have some tags we can put on there, and again, that's going to be covered in the advanced area. But we can also choose not to advertise the summary route, even though we have it typed in. But I'm just going to keep that summary address in there like I wanted it. And at this point, I should be able to hop up to router 2 or 3, both of those backbone routers. Let me hop over to 3, do a show IP route, and now we can see right there 172.30.0.0/16. They've all been summed up into one route. All the more specific routes have disappeared from the table. In this nugget, we have laid the core competencies or the fundamentals of OSPF and started putting together our OSPF network. We started it all off, and I'm sure when you first saw the initial network diagram, you thought, wow, that looks simple. But we did start off simple with just the Ethernet configuration of Area 0. We took a look at how the DR and BDR ended up that way, the DR other relationship, and how on that Ethernet segment, some of our routers may form that two-way relationship with the the DR others, the non-DR and non-BDR routers. That's not something that's bad, that's by design. We then got into adding the additional area support. And boy, was there a lot with that one statement. We got into the normal areas, the stub areas, and the totally stubby areas, showing how to configure each and then also what the impact of that is on our network. We then got into inter-area summarization and even wrapped it up just a moment ago with summarization from an external domain. One of them uses the area range command, the other uses the summary address command. And of course, spliced in there, as soon as we got into the stub area, we connected and redistributed to, in this case, the external RIP version 2 domain to bring external type 2 routes into our network. I hope this nugget has been informative for you, and I'd like to thank you for viewing.